All right, let's go ahead and solve problem 953, letter A. Now, you might notice that it's equal to 12, but it needs to be equal to what? Or less than, it says in this case. It needs to be equal to 0. So step 1, let's move that 12 to the left side. Pretty straightforward. Okay, we're going to get x squared plus x minus 12, and let's just go ahead and write that down as equals 0. Our next goal is to find the boundary points. What numbers would make this equation true? So let's just factor this. Factoring is one of the quicker methods. If it's not factorable, we can use other methods, but let's see if this is in fact factorable or not. So here we have what two numbers multiply to negative 12? Multiply to negative 12 and add to 1. So what two numbers multiply to negative 12 and add to 1? Okay, I'm going to go ahead and write this as x and x. But what would happen next? What numbers multiply to negative 12 and add to 1? Let's see. Yeah, I think it'd actually be 4 and 3, but 4 and negative 3 would be what works. Okay, so let's go ahead and write those numbers down. 4 and negative 3. That's the factored version, okay? So our next step is to just use the zero product property to find out what our boundary points are. So our first boundary point is going to be at negative 4 by switching the signs. And the second boundary point is going to be positive 3 by switching the signs. Good job, we did it. So our next step here is to go ahead and graph this on a number line. So we're going to go ahead and put 0 down as the center of our graph and just draw the number negative 4 and 3 where it would look realistic. Of course, you can add the number lines to make it work or to be a little bit more visual, but it's just not 100% necessary. Now, let's graph these numbers there on our number line. But the only thing I can do is I have to decide whether it's a closed dot or whether it's an open dot. So if I take a look at our sign here, the sign tells us everything, right? If it is going to be a closed dot, that means it's going to be greater than or equal to or less than or equal to. I only include the closed dot if it includes those numbers. Okay. My second option is going to be an open dot, and that only works, like this case, letter A, if it's greater than or equal to, greater than or less than. Only these symbols. Since we do not see an equal to sign, that means it's not going to be filled in. It's going to be open. It does not include the number. So for this case, as we can see, it's going to be an open dot. So I'm going to go ahead and put an open dot for those boundary points. All right, next up, I need to decide whether my solutions, and I'll actually just go ahead and copy paste this here for a second. I got to decide if the solution is going to be looking like this, where the solutions are on the outsides, or if my solution is going to look like this, where my solutions are on the inside. So these two are my only two possibilities, is that it's going to be sort of thumbs out in region A and region C, Or my second possibility is that my solutions will be in region B. Okay, so we got to decide which of these two it is. How I'd like to do that is by testing a point. Okay, what I'm going to do now is test if I'm going to go ahead and test if 0 is a solution. Now 0 is the easiest point to try out. So if I take my equation x squared plus x is less than 12, the original equation, right? And I just plug in the number 0. Let's try it out. What happens if I plug in 0? 0 squared plus 0 is less than 12. We're just checking if 0 works. So what is 0 squared plus 0, right? 0 squared plus 0, that's just 0. Let's decide if this is true. 0 is less than 12? Yep, that's true. So 0 is a solution. That means it's very likely, if I didn't make any mistakes, that our solutions will be everything here in region B. Everything in the middle there. Okay. One last step. Let's just test. Let's just test if it's possible that a number in region C might be a solution, because it's oftentimes we could just make a mistake. So let's try a different number in this just to confirm that our answer is true. Okay, here's our inequality, our equation inequality. Let's try plugging in the number that is in region C. Now, what numbers are in region C? We got anything greater than 3, so 4, 5, 7, 7.5. Let's try plugging in a random number that's greater than 3. Let's try plugging in 5 and see if this gives us a true statement. So 5 squared plus 5 is 25 plus 5. And as you can see, 25 plus 5 is not going to be a true statement, meaning anything in region C is not going to work. And it's going to be the same thing if we try any negative numbers that are less than -4. So I can go ahead and confirm that my answer right here right there is going to be true. So here's the other way to write my answer. X is less than 3, but x is also greater than -4. So both these answers are the same, and both those answers would be accepted. We're done.